You. How are we doing? I know we're running a little late, but it's a time of the afternoon when after lunch. Ooh. So I invite you to take a deep breath in if you like to take a moment. It does help. So my name is Alberto. I am the CTO at Sage Bionetworks, and data. We need to chat. So no spoiler alert necessary here. I will be talking about a LLM powered conversational agent that we built at Sage as an experiment to enable biomedical data discovery and exploration. So we're awash in data. We've been talking about data for the last 3 days, but I believe we still are having trouble finding it. And when we try to use it, sometimes we end up drowning. Um, Specifically for us at Sage, because one of our missions is to actually bring as many eyeballs to data as possible. So a lot of us here are experts, but actually we're trying to provide data to patients, communities, and people that don't know how to search for data. So what if we could simply talk to our data? So that's the core of my presentation today, making biomedical data sets more discoverable, accessible, and ultimately useful through conversational AI. So you probably already heard about Sage Bionetworks, and I have a couple of people here in the room to support me, but I'm just gonna have to say a couple more words about who we are. We're a nonprofit organization. We're based in Seattle. We're heavily mission driven. I told you before, one mission, which is to bring as many eyeballs to data as possible, but our official mission is to drive a new age of discovery through genuinely open science and radical collaboration. Luca, our president, gave a presentation yesterday in the NIH track, and he said that what we do is open science with protected data. Sushil, who's in the room, described it yesterday in the BOSC track a little different. He said that we do the unsexy work of managing and wrangling data, curating data, validating data, and doing governance to make biomedical data useful to as many people as possible. We operate in about 20 therapeutic areas, from cancer to Alzheimer's, and from ALS to neurofibromatosis. And of course, for a lot of the areas, we build and manage knowledge portals. Sushil yesterday talked about the AD knowledge portal and the Elite portal. But most of the work that I'll discuss in the next few minutes is actually mostly implemented on synapse.org, which is our flagship platform. So it's a data repository, mostly for biomedical data, and it supports multi-institutional research. It supports the research needs around structured, versioned, and discoverable research data. The important thing is that we host about 3.5 petabytes of data and counting. And while we are, as I said, fairly domain agnostic, we mostly support and host clinical data, multi-omics, imaging, and digital health data. Very importantly, Synapse is built with governance in mind, so it's made to protect and manage the privacy of sensitive research data. So I said 3.5 petabytes of data. Sounds like a lot, but of course, Synapse is just a small drop in an ocean of biomedical data, which is accumulating at a very fast and unprecedented pace. So from genomics to imaging, clinical EHRs, we're now entering the zettabyte era. But if you actually look at data use and reuse, we're actually not experiencing as much use and reuse as we'd like. So if I take Synapse as an example, only about 20% of our data is typically downloaded on a monthly basis. Why is that? Well, it's, as the article up there says, maybe because just opening data is not enough. I believe that maybe the tools to navigate the biomedical landscape are probably still rooted in a fairly outdated paradigm. Maybe the fact that I'm actually using data downloads to describe use is the beginning of the problem, right? Maybe we shouldn't really compare downloading data with reusing and using data. Another message that we hear frequently, down here in the second paper, is that a lot of biomedical data is open in appearance only. So while the data may actually be available for general research, there are barriers to access. And nothing exemplifies this better than seeing what AI researchers have to say. AI researchers that, of course, may be very hungry for biomedical data. And in a recent survey run by Nature, AI researchers indicated that lack of data to run AI on is actually a significant barrier to progress. So it seems like there's an interest in data. There's a lot of data out there, but the general public is still finding it hard to find. So why is that? Imagine you are an AI researcher and you're trying to find data about the interplay between Alzheimer's and type 2 diabetes. This is actually an example that came in one of the presentations yesterday about the Common Fund Data Ecosystem, CFDE. So you might start with Google, then land on a repository, face some clunky interfaces. Again, remember, this is probably a non-biomedical expert, someone who just works in AI. You might end up finding inconsistent, non-harmonized metadata, and then face access restrictions, which again, a lot of AI researchers are not familiar with. So what you'll find is that biomedical data is fragmented across silos, and it's buried under sometimes very vague descriptions or metadata. So this is because searching for data is not like searching for documents. Traditional search interfaces that were built for documents don't support this sort of non-linear, iterative refinement and exploratory approach. And here I'm citing the work of Gregory and Kosten, who are also recent collaborators of ours, that say that finding data is a non-linear, iterative process. They actually came up with an entire framework. I mean, they wrote a book also on how, on human-centered data discovery that is unlike the discovery and the search that we perform on documents. When looking for data, we have multiple steps. It's a multi-step, multitask process. And you also need to understand what's inside the data set, evaluate the structure, the quality of the data, assess the suitability. So you need to ask, what's the cohorts? What's the assay? Is the data normalized? But there's more. You need to do all of that, ask all those questions, sometimes before seeing the data itself. And that's because most health data is controlled access. And this puts a lot of the data discovery process, including the important part, which is there to the right, which is the data exploration and data use, behind a curtain. So this sometimes leaves hundreds of petabytes, if not more, of health data fundamentally undiscoverable. So it's dark data, like dark matter. But it does not have to be this way. How can we shine light on dark data? So at Sage, we're doing this in 4 different ways. Each emoji is for one way that we're looking at. So the first one is that we started publishing leaderboards for the most popular and trending datasets and projects on synapse.org. Hugging Face style, in a way. Then we recently implemented croissant specifications for all of our datasets to make our repository Synapse machine learning and AI ready. We're experimenting with synthetic data. Sorry, that's the best emoji I could find for synthetic data. So a simulated replica of data, which does not contain any sensitive information and allows users to look at the data, download it, explore it as quickly as possible without having to worry about governance and access restrictions. And finally, we're shining light on dark data by implementing what I'll talk about for the next 6 or 7 minutes, which is the ability to have an LLM-based solution to allow users to chat with a data set before downloading it, so that we can really try to pull the curtain open on dark data. So I did show you before the homepage for Synapse, which I can actually go back to it for just a moment. So this is what it looked like until about a year ago. So you can see like we actually revamped the homepage so that we put the search bar right at the top. We added some like search chiclets that allow you to like in one click get to a search term. And of course, we're constantly trying to improve our actually search framework to enable, as I said before, as many eyeballs as possible on data, to find the data as easily as possible. But very recently, we also added a new, if you go to the homepage now, you'll find that you get this selector where you can pick between searching, doing a traditional search, and then chatting with Synapse by asking a question. Again, this is only available on synapse.org at the moment. As I said before, we also run a number of portals, and we're thinking and hoping to also add this kind of functionality to portals. And of course, in that case, the chat functionality would be limited to the perimeter of the knowledge portal itself. So you can now use natural language to search and ask questions on Synapse. If you ask a question, the chatbot will interpret your user query, translate it into a search request, then retrieve relevant metadata, and also tell you why it picked specific projects or specific data. So the idea here is to lower the barrier of entry for biomedical research and also experiment with new ways to search data, right? It's almost like asking a colleague or an expert a question, receiving an answer, and then trying to refine the question and asking more specifics about a specific data set, maybe asking what's inside the data set, and so on and so forth. So let's ask the chatbot a real question in plain English. So here I asked, this is from yesterday, I need data sets to study the epigenetic signature of malignant peripheral nerve sheath tumors, MPNST. Please help me find this data. So it's a traditional search that I could just do specifically, but what I'm doing here, I'm combining two specific parts, epigenetic signature and then MPNSTs. And as you can see right away, as soon as I ask the question, the UI of Synapse Chat starts telling me what it's actually doing in the background. So this is the trace, the thoughts of the chatbot. And it's saying, I'm just gonna perform a search, then I'll display the research results in a table, finding relevant projects. Next step, it's the second thought, let's just say the second trace in the process is that it's telling me, I found several relevant projects studying epigenetic mechanisms and potential drug targets for malignant peripheral nerve tumors. And it's starting to already list some projects there. So it's an initial attempt. And then finally, after a little bit, we have not improved and really refined this for speed. It still takes about maybe 25 to 30 seconds to get some search results. You get search results which are really nicely condensed. In this case, like there's 3 projects that were highlighted. What's interesting here is that we're getting high-level description about the project. We didn't have to like click, just search and then click on links. We're getting a nice compendium of like 3 projects that have to do with epigenetic mechanisms and the specific condition that we looked for. And of course, like for each one, we get a link to the specific scene ID, which is the project. So you can just click on it, and that allows you to get straight to the scene ID, to what you're looking for, hopefully. But there's more. I can keep on chatting with the system. So in this case, I asked, can you suggest ways in which I could combine these projects? Actually, I meant, can I combine data from these projects? And after a while, I did get 4 different avenues in which maybe data within the projects, so we're now starting to look at the metadata, actually could be combined, it could be made sense of. So it's providing and proposing, I know there's a lot of text here, 4 different avenues. And what I can do next is I can say, I really enjoyed the 3rd avenue you proposed. So I can just say, please let's keep on exploring the 3rd one you suggest. Can you summarize the available data as a table? And so we're getting here some more narrative and analyzing the combination of like 2 specific projects and key findings and potential therapeutic implications. So it's just a way to, as you can see, what we're providing here is a richer interface for users, specifically users that maybe are not necessarily familiar with biomedicine, to actually start analyzing and getting data and potentially combining data from different projects into one. But I believe that we're possibly only scratching the surface of what's possible. A new idea that we're developing, and here again, Sushil was the inventor of the word metadata spelunking, which I hope I'm pronouncing correctly, is the ability to explore what's inside a data set without the need to having direct access to the raw data. So once we have identified a data set that we're interested in, or maybe a combination of them that we can like bring together through the chatbot, then we can start asking questions about the data itself in the data set. How many participants are there? What age ranges are we looking at? What diagnostics criteria? I think that this is not just useful, it's actually essential to do privacy preserving discovery. And you get to understand the value of the data without necessarily like having to overcome protected information barriers and access requests. Just a few words about the actual architecture and how we implemented it. For the most part, there's no magic sauce. We just use off-the-shelf tools and technology. At the core, we built a baseline agent. And if you actually go to the QR code included here, you get a link to the AWS CloudFormation template sitting on GitHub that pretty much defines the baseline agent in detail. Everything we built is open source. And what I'm showing here is just a very basic illustration of the RAG-based chat interaction. So the UI, the Synapse chat, captures the user's intent through a prompt in natural language, sends it to the baseline agent, parses the text, invokes specific Synapse APIs, and then the results are passed through an LLM to give you a structured response. So basically, we implemented a worker architecture in our APIs. The worker can then invoke agent calls to, at the moment we use AWS Bedrock, and the baseline agent is currently configured to use Anthropic's Claude 3 Sonnet as its large language model. The important thing to note here is that as I showed you before, the agent will keep the context of each interaction, so that and that becomes apparent when you're talking to the chatbot for a while, and then you can say things like, tell me more about the third result, for example, because we have that session. Now, just a couple more points and then I'll be done. This is probably the most important thing that we've done. Actually, if I go back to some of the examples, you'll see that in the top right, you have an access dropdown. That's actually probably the most important thing that we have built. It's the idea that we can actually determine what kind of access level you give to the agent. So the Synapse authentication and authorization system manages all of the data access requests for the model, which is why you can only use, I probably didn't mention it, you can only use the Synapse chatbot. If you're looking at synapse.org right now, you will have to log in order to use the chatbot. So we don't rely on secret prompt engineering to keep data safe. All the model interactions occur within a Synapse managed chat session that belongs to the user. And so the private data that is shared during a chat session cannot be shared with anyone else. And the session will never contain any data the user is not authorized to see. So in each session and with every prompt, you can actually change and switch to a different drop-down option. And so you can rely on just viewing public data and allowing the model to view public data, or you can allow the model to also read your own private data and everything you have access to within Synapse. So if you have access requests on a lot of data, the model can actually read that. And then the most exciting part, and then I'll end in just 1 minute, is the ability to not only read, but also write data. So the curator then the chatbot becomes an agent with operational power in a way. And that's what we're doing next. Luke actually shared this slide yesterday. And And we're building ways for the chatbot to actually become useful for important tasks. Tim, who was speaking before me, said that biology is very diverse. And it's true because researchers across different domains, institutions, they're collecting, annotating data in many different ways. And for us at Sage, harmonization is key. But curating data takes a long time. So that we believe that enabling a chatbot that can not only read, but also write and operate on data is fundamentally important and really paves the road for a more interoperable, multi-institutional, multi-domain collaboration in biomedical science. That's us at Sage. Thank you so much.